Hello viewers, I am Kausalya. Today we are going to solve problem number 3 and 4 under the topic nodal analysis. So here the problem is solve the network by nodal analysis and find the power supplied by the sources. Right. So here in this problem, how many sources are present? Here we are having totally 2 current sources. Right. So we need to calculate the power supplied by the current source. So first we will start with the numbering the nodes, right? So here we are having 4 ends, right? That is 4 points. You see, to this point these 3 elements are connected, and to this point again these 3. Similarly for this node as well as for this node, right? So in nodal analysis it is a usual practice that we should always have a reference node, right? So here node number 4 is taken as reference, right? So while forming matrix, so we will be having a 3 by 3 matrix, right? Since 4 is a reference node, we are having only 3 nodes under consideration. Therefore, we have to frame a 3 by 3 matrix. So that is our first step here. So you see, again, to this node 1, how many resistors are connected? Here we are having 2 resistors. So you have to take the reciprocal and you have to add it. So 1 by 2 plus 1 by 2. Again, when you look at this node 2, here we are having these 2 resistors, right? 2 and 4. So that forms the diagonal element. So 1 by 2 plus 1 by 4. Similarly for node 3, you see here again we are having 2 resistors, right? This 2 ohm and this 2 ohm. So when you add, so that gives 1 by 2 plus 1 by 2. Right, so they form the diagonal elements here. Right, so the next thing is again a common element between your node 1 and 2. Right, so we are having 2 here. So while writing common elements, we have to include a minus sign. So minus 1 by 2 and here minus 1 by 2. Again, when you look at node 1 and 3, yes, we are having a 2 ohm resistor here. So therefore, again it is minus 1 by 2 and here also minus 1 by 2, right? These are all the things I believe you people know. 1, 2 and 3, okay? Between 1 and 2, that is element which is common between node 1 and node 2 is written here, and node 1 and node 3 is written here. Right, similarly node 2 and node 1, node 3 and node 1. Right, now the next thing is there anything common between the nodes 2 and 3? No, we are having only a current source here. Therefore here just write it as a 0. Right, and again the respective voltages are V1, V2 and V3, and here we have to write the respective current sources. So to the node 1 we are having 8 amps, right? So write it as 8. Again for the node 2 we are having a 10 amps, so write it as 10. Again for node 3, you see, for node 3 this 10 amps is moving away. Therefore here you have to write it as minus 10. Right, so this is our first step and it is an important step. Once you have done correctly with this, then the rest of the things will be easy. Right, then the next thing is we are solving, right? We are solving this matrix. So here we are ending up with a matrix like this. Right, now the next thing is we are going to calculate the values of V1. So what is the formula for V1? It is delta 1 by delta. What is meant by delta? When you take the determinant of this matrix, that will give you the delta. How to calculate del 1? Again we have to take the determinant, but we have to replace this first column with this element. Right, so first we will start with delta. You see here we are calculating the determinant of this matrix. Right, so I hope you people are familiar with the determinant, right? So you see 1, so you have to leave this column and this row. So 3 by 4 into 1 minus 0. Right, so 1 into 3 by 4. Again here while analyzing it should be plus, it should be minus and it should be plus. So minus into minus becomes plus 1 by 2. Again you have to leave this column and you have to leave this row. So minus 1 by 2 into 1 gives you minus 1 by 2. Right, the next thing is minus 1 by 2. And again here you have to leave this row also. So this is 0 minus of minus 1 by 2 into 3 by 4. So that gives you plus 3 by 8. Right. So once you solve here, we are ending up with the answer as 5 by 16. So here we have calculated del 1, right? That is the first column of rows are replaced by the source elements, source values. So again, when you find out the determinant value, the value of del 1 is given as 29 by 4, right? And the next thing is to find V2. So to find V2, what is the formula? Del 2 by del. So the value of del is already calculated. We have to calculate del 2. So the del 2 is given by, again the thing is, you have to replace the second row by the source values. Sorry, second column by the source values. Right. So again, when you calculate the value, the same thing, you see 1. 10 into 1 minus 0, therefore 10. Minus 8, right? You have to leave this. So when you multiply minus 1 by 2 into 1 minus 0, so therefore minus 1 by 2. And here it is minus 1 by 2, so I just leave it. So minus 1 by 2 into 10, right? Plus, because here minus into minus plus 10 by 2. So that becomes 10 by 2 plus 10 by 2. Right. Once you solve here, we are getting the answer as 9. Now we are proceeding with del 3. Again, the final column is replaced by the source values. So again, when you solve, you see you are finally ending up with the answer as 1 by 2. So now we have calculated del 1, del 2 and del 3. So here we are calculating the respective V1, V2 and V3, right? So V1 is del 1 by del, V2 is del 2 by del and V3 is del 3 by del. Just substitute the values and find out the answers, right? The next step is we need to calculate the power supplied by this 8 amp source, right? So again look back at the problem. You see the power supplied by this 8 amps, right? So power is given by the formula V into I. Right? So we know the I here. If we know the value of V here, then it is easy to calculate the power. Right? So here the value of voltage is V1. We know the value of V1. Right? Therefore just substitute it here. So the value of V1 is 23.2. So 23.2 into 8, that gives an answer of 185.6 watts. Right? The next is power supplied by the 10 amp source. So, here 10 amps is connected between node 2 and node 3, right? Therefore, the power is again given by the formula V into I, okay? The I is 10. Since the current source is connected between two voltages, we have to subtract V2 minus V3. So, when you subtract, you see the final answer is 272 watts, right? So here comes the end of our third problem. Now we start with our fourth problem. Find the potential difference between nodes 2 and 4. Right. So in this problem they had clearly mentioned the nodes. Right. So you need to calculate the potential difference between node 2 and node 4 here. And totally here we are having 3 current sources. Right. So among the 4 nodes, again we are taking node 4 as a reference node. So here we are framing the matrix. So again when you consider your node 1, right? So to the node 1, how many resistors are connected? This 1 ohm and 2.5 ohm. So therefore 1 by 1 plus 1 by 2.5. Right. Again, when you look at this node 2, how many resistors are connected? This resistor 1 ohm and this resistor 2 ohm. Therefore, here also another resistor 4 ohm. So totally 3 resistors. So just take the reciprocal 1 by 1 plus 1 by 4 plus 1 by 2. So again when you look at this node 3, how many resistors are connected? 2 resistors are connected, right? So it is 1 by 2 plus 1 by 5. Right, now the diagonal elements are over. The next thing is the resistor which is connected between node 1 and node 2 is 1. So here you have to take the negative sign. So here it is minus 1. So again the resistor which is common between node 1 and node 3, there is no common resistor. Therefore, here it is 0. Again, resistor which is connected between node 2 and node 3 is 2 ohms. Therefore, here minus 1 by 2 and here also minus 1 by 2. Right. And as usual, the voltages are V1, V2 and V3. And again, you see, to this node 1, the 4 amps is coming towards node 1 and 3 amps is leaving. So 4 minus 3, so that gives the answer as 1. Right, therefore here it is 1. And the next thing is, again when you look at node 2, 3 amps is coming towards and 4 amps is moving away. Therefore 3 minus 4, that is equal to minus 1. And again when you look at node 3, you see 4 amps is coming towards node 3 as well as 4 amps is moving out of node 3. Therefore 4 minus 4, so that gives the value of 0. Right. So here again when you simplify the matrix, we are getting an expression like this. Right. Now the thing is, we need to calculate the potential difference between node 2 and 4. So we need to calculate V2. Right, because node 4 is a reference node, so no need to find V4, we need to calculate V2 alone. So V2 is given by del 2 by delta. Right, so here the delta is, when you take the determinant value of this matrix, that will give you delta. Right, so therefore here the value is 0.665. Right. And the next thing is del 2. So how to calculate del 2? Here you have to replace this second column element by this source element. Right. So when you replace here, you see, we are getting a matrix like this. Again, when you take the determinant value, here the value of del 2 is minus 0.28. Right. So now we are going to calculate the V2. So V2 is nothing but del 2 by del. Just substitute the values here. So here the answer is 0.42 volt. That is, the potential difference between node 2 and node 4 is 0.2 volt. Right. So here, since node 4 is taken as reference, so the value of V4 will be 0. Right. So no need to calculate. So the only thing is, once if you are done with V2, that is your final answer. Right. So here comes the end of these problems. If you have any doubt, let me know in the comment section. Thank you.